All right, guys, welcome to week 6. I can't believe it. It is flying by. This is already 6 weeks. It's an 8-week course. That means we have 2 more weeks after this one, and really weeks 5 and this week, week 6, even next week. This is kind of the heart of, I would say, of the course because of the importance of factoring polynomials and how it relates with algebra. It really unlocks the ability to do quite a few things. So you have to spend a little bit more time, in my opinion, with factoring with students in order for them to have success in Algebra 1 or Algebra 2 later on their junior year. So anyway, we're going to go and get started. We got Chapel back from vacation. Woohoo! She survived the boat ride. We got Elena, who is surviving right now. She got a little bit of a bug, but she's fighting through it. And then we might have a couple people watching replay, it looks like today. But anyway, I'm going to go ahead and get started by reviewing a little bit from last week's assignment. As a reminder, try your very best to get your assignment back to me, either text or email, before class starts. I know that's not always possible, but that's still kind of the goal that we're shooting for, right? So those of y'all who got that in on time, thank you for that. I want to ask permission from one of our students because of some of the work I saw. I like some things that you did that I think could help the other students. So that's my reason, my main reason for asking. Chapel, are you okay with me showing the group some of your work that you turned in before class? Is that okay with you? That's not going to embarrass you or anything?
No.
Awesome. All right. Whoa, what a champ. What a champ. Give it up for Chapel because I want to use your work on a couple areas. Now, there is one area of Chapel that I got to make a little tiny correction. It was mostly good, but there's one thing I need to point out that probably other students need to learn as well, not just you. And then there's another way that you were doing the factoring process towards the end that I really like how you set it up. And I said to myself, wow, maybe I'll teach it that way going forward. I like to learn from my students just like they learn from me. So I'm going to go ahead and share her work. If that's cool, let me go ahead and pull that on screen so everybody can see it. Um, okay, you know it's her work because the handwriting is a lot better than it would be if it were my work. Okay, so here we go. So even though you weren't here, I think Chapel and I were talking before class. Even though she wasn't here live, she watched the replay and she said, Chris, for the most part, your explanations on the video still made sense. So I'm believing by faith. Those of y'all who aren't here live are going to get the same benefit that Chapel did last week if you didn't get a chance to catch the live class. Please pay attention. So if you remember, we were learning a process called GCF. Now, who can tell me what GCF stands for? There's only two of y'all live right now, so I know I shouldn't have to wait too long. What does the G and the C and the F stand for? Who's going to go?
Greatest common factor?
Thank you for raising your hand so politely, Chapel. And Elena, thank you for just blurting out the truth. I know you couldn't help it because you love math. It is true. I'm not mad at you. It's greatest common factor. That's what it stands for. Is that what you're going to say, Chapel? Or are we going to
Yeah.
say Gary Chapman? I don't know. Okay. Greatest common factor. So whenever you're doing this process, now there's a few different steps that kind of work your way into understanding this, especially that first page. But what I really want to look at, I want to look at this second page. This is where most of the examples that y'all had to think through on your own without guidance kind of showed up. That page 4, as you can see right here, but really page 2 if you're talking about just last week. Now, the first set of questions, we're only asking you to find the GCF. Find the greatest common factor between two terms or three terms. It just kind of depended on the question. But if you look like number 5 right here, it says 9x and 45. 9x and 45. These are two terms that, in a sense, are being compared with one another. Okay? Now, I do have a little correction I want to make here, and Chapel has graciously agreed to be my little guinea pig today. She doesn't care. Okay? And I'm going to talk to you guys about this. But for something to be a GCF, it has to be in common to both terms. And I think I know, Chapel, what you're thinking, but I have to do a slight correction. I want to hear what you guys think after I mention this, okay? But if you have 9x and then you have 45, those are two different numbers, two different terms. And what you're really asking yourself is, as I said last week, what do you have in common? You know, imagine 9x got asked to go on a blind date with Mr. 45 and they're at coffee or they're going out to eat at dinner and they're like, oh, tell me about your life. Tell me about what do we have in common? You know, if this is going to work out, we have to have something in common, right? Well, if you think about 9, not even the 9x part, but let's just look at the number 9 compared to 45. You have to think about the factors of 9. And then you have to separately think about the factors of 45. And you have to ask yourself, are any of those in common with each other? Now, the good thing about 9 is there's not that many options that go into 9. When I say factors, guys, I'm saying what times what can you think of that equals 9? So it's really a multiplication drill at the end of the day. So I'm gonna start with you, Chapel, since you raised your hand so politely. Appreciate you. Can you give me two numbers, just two at a time, something times something that you know that you know that you know that you know equals 9 if you were to multiply them?
3 times 3.
3 times 3. Give it up for Chapel. Very good. 3 times 3 is what most people think of. Okay. There's only one other combination that would work, but I'm just going to put 1 3 up there because it's the same thing. I don't have to put it twice if it's the same number, right? But there's one other set that works. It's so obvious people forget about it. But I'm going to go to Elena for this part. Elena, turn her off the mute. What other two numbers can be multiplied together, Elena, that would also equal 9 if multiplied? Elena.
9 and 1.
Thank you. Don't forget 1 times the actual number itself also counts because I can multiply 1 times 9 and get 9. So these are the three numbers that are factors of the number 9 right here. Is everybody with me? Give me a hand up in the camera if you're with me. That makes sense to you. Okay. So this is all I bring to the table. I'm a simple guy. I'm a simple girl, you know? I only got 1, 3, and 9. There's not anything special about me, all right? That's what I got. Do we have anything in common? You know, I don't know. Maybe that's how the date went. But now we're looking at 45. 45 is a larger amount. It probably has more factors than just 3 of them, right? But let's go back to Chapel. Chapel, any two numbers that you can think of, something times something that you know, if you multiplied it would equal 45. What do you say?
9 and 5.
9 and 5, absolutely. Okay, that's the first combination I thought of. So we already can see something in common there, right? But there's more than that. Let's go to Elena. Elena, can you think of anything else? Because that's not the only combination. Is there anything else that you know multiplies to equal 45?
This is not my strength.
Not your
Is
strength, but you're
it
gonna try anyway, right?
3 and 15 maybe?
Oh,
I think.
very good. A lot of people don't think about that, but that's true. 3 times 15. Now, that's not one you would have memorized in third grade. You would have just kind of figured that out as you got older, right? But 15 plus 15 is 30. Another 15 would be 45. So 3 times 15 would work as well. Can I just go ahead and get this out of the way in case some of y'all are thinking about it? 1 times 45 also works. Can we just get that out of the way? Okay. Anything times 1 in itself equals it. Okay. Now, here's the thing, Chapel. Here's the thing, Elena. Here's the thing, Marcelo. Here's the thing, Rachel. Here's the thing, Eliana. It's not enough to be in common. It has to be the greatest thing that we have in common for this process to really work the way it needs to work. Now, I see a couple things in common. 1 and 1 are in common. We each got a 1. Okay, big deal. Everybody has a 1 in common. All right. We also have a 3 and a 3 in common. Chapel, I'm not picking on you, I promise. But would you still agree that 5 is a number that's in common to both now that we took a second look at it?
No.
No. See, 9 times 5 equals 45. I think you were thinking of it that way. What can I
Yeah.
multiply? That's probably what you're thinking. And I used to do that. That's pretty common, but that's not really what we mean when we say what's in common. It has to be all the numbers that multiply to 9, all the numbers that multiply to 45. What number shows up in both lists? And Chapel, now that you got another chance to look at it, what number would you say is in common? And it's the biggest thing that you see they have in common.
9.
It's the 9. Don't get down on yourself, okay? Learn. You either get it right, yay! You got a lot right here, okay? There's a lot to celebrate. And now we get to learn. Yay! I'm smarter than I was yesterday. This is, it just gets brighter and brighter. So 9 would be the true GCF on question 5 right here because 9 is actually the biggest number that shows up in both lists. Does that make sense? All right, Chapel's with me. All right, okay, I appreciate you. A lot of people are like, I don't want you to use my work. I don't want. Hey, it's a team effort here. Elena, does that make sense to you? Okay, we cool? So that's either physically write it out if you need to do that. Some people are visual. They need to see all 1, 3, 9, 5, 9, 15, 3. Some people need to see it with their own eyes, and some people can keep it in their brain. I don't know what kind of person you are, but just do what you got to do and pick and figure out the biggest number they have in common. Okay, so let's take a look right here. This is a very similar one. Uh-oh. Elena, you showing up twice? I see another Elena entering the classroom here. This is interesting.
This meeting is being recorded.
New
Yeah,
device.
I'm going on nine.
Oh, Elena. It's on. Oh, that was terrifying. Okay, I got to mute one of Elena's. Okay, I muted one of them. Oh, yeah. First round, yeah, math, algebra. Okay, so look right here. I want to do a second look, Chapel. I want to do a second look, Elena's. Marcella, Raquel. No, Raquel's the mom. I'm sorry. She likes to participate too, though. Okay. I want a second look at this. Now that we had that discussion, you got 7x squared. What goes into 7? What times what equals 7? What times what equals 21? Make a list physically or list it out in your head if your brain works like that. Whatevs. But I want the biggest factor, the biggest number that works in both camps. Chapel, you
7.
still sticking with 3 here? That's what you said on the homework. I want to see if you're still sticking. You don't? Nope. You seem like, yeah, you're rethinking some things. Okay, that's all good. You got another thought now that we had that discussion that you might go with instead, Chapel?
7.
Thinking 7?
Mhm.
Wow, you said that with some authority. See, 1 times 7 is the only thing that equals 7. It's a prime number. That's the only thing that equals 7. And I know 3 times 7 is 21. 7 is the biggest thing they have in common. Does that make sense? So if you can do it in your head, more power to you. If you need to list it out like I'm doing on screen, do so. Mr. Morris, does that mean the answer was actually 7? No, Mickey Mouse. That was part of the answer. But they also have an X in common. Don't forget, not only am I looking for the coefficient, that's the number part in front. What's the GCF there? It's 7, like Chappell said. But if they each have at least one X, hey, I got to include that one X in my GCF as well because they each have an X. One has 2 X's, one has 1 X, but they each have at least one X. So I'm looking for both parts if you have these types of terms. Are y'all with me or not? Give me a thumbs up if that makes sense, the variable, all that. Okay, so we're getting some right. We're getting partial of it right, but we're learning somewhere. We can always get better. Okay, stay humble, stay with a good attitude. Okay, I'm liking this one a lot, actually. I think the biggest thing that's in common between 18 and 12 is 6. Chapel, this is better. Mm-hmm. I think it's 6 times 3 is 18 and 6 times 2 is 12, right? 12 don't go into 18. So there's nothing bigger. Okay, 6 makes some sense to me, but I need a variable too. No, sorry. I need a variable as well. Okay, not the number 2. Okay, TOO. Okay. I need a variable too, and I need to know how many of that variable. Y'all with me? Let's go to Elena on this one now that you figured out what device you're on. You were really confusing me for a minute. Okay, Elena. This one has 6 x's. This term over here has 3 x's because it says x to the 6 over there and x to the third. You see what I'm saying? But what's the most amount of x's that each term has, Elena?
3 X's.
3 x's. And Elena, stay on there. Nope, you went away. Come back. How do I write that the right way, Elena? What did we talk about last week? How do I write it if it's 3 x's? What's the easiest way to say that and write it?
I do not remember.
Oh, yes, you do. It looks a lot like this. Do you know how to say that the right way, Elena? How do we say that properly?
3 cubed.
X cubed. You can say it
X
that way.
cubed.
Cubed is a reference to the exponent of 3. So you don't have to say 3 and then cubed. Cubed means 3. It's x to the power of 3, or you can say x cubed, okay? But that's also considered, Chapel, that's also considered, Marcelo, part of the GCF. Not only is 6 in common, yeah, those are the coefficients, but they each have at least 3 x's. And so we have to include that in my GCF. Are y'all with me today? Okay, Elena, say it loud and proud. It's x cubed. X cubed. Okay, try to remember that. Or you can say x to the third.
X cubed.
There you go. Very good. Chopper, you want to try it? X cubed.
X cubed.
Very good. All right. You can say it either way. Cubed means to the power of 3. Okay, so you don't have to say it twice. 3 cubed. Okay, cubed means 3, so you're kind of being redundant, right? It's x to the power of 3, meaning there's 3 of them. Okay, very good. We're just cleaning up a couple things. Okay, now now that I picked on Chapel a little bit, okay, I did. I totally picked on her, but she gave me permission, so you can't get mad at me, Chapel. I want to commend you on something different that you did. Now, for whatever reason, when it said factor by polynomials, You were including the variable. You were rolling. It's almost like it was interesting. That was definitely in your thinking. Okay. So I know you know this. But what I like that you did, let's talk about this for a minute. What Chapel did well, and I like the visual, is Chapel looked at this original polynomial, 6x squared minus 24x, and she said to herself, what's the GCF? What's the greatest thing they have in common? 6x squared was looking across the table at Mr. 24x. You're cute. No, you're cute. No, I think you're cute. Okay, that's how it is. And they said to themselves, what's in common? Do you like dancing? Do you like swimming? I'm Elena likes swimming. Okay. Do you like that? What do we have in common? Okay. That's how it goes when you're old enough. Okay. Well, they sat down and they talked it out and they said, well, I'll tell you what I got. These are the things I like. If I'm 6x squared, I like 3 times 2. I love going to 3 times 2. I like to go catch a good 3 times 2 at the movies. I like 1 times 6. Uh-huh. 24 was like, I like 8 times 3. I like 6 times 4. Uh-huh. I like 2 times 12. I like 1 times 24. These are the things I like. What's the best thing we have in common? I want to go out again. Well, I'll tell you what. 6 is in common. 6 goes into 6, 6 times 1, and 6 goes into 24. That's 6 times 4. So 6 is the GCF, but also, Chapel, good, the X. Y'all see how there's an X squared over here and there's an X over here? Well, what do they got in common? They each got an X. Mm-hmm. Uh-huh. That's right. I used to have this aunt who, when she went to like old school black church up in Philly, that's what they do. You participate in the sermons if you go to a church like that, old school black church in Philly. So when the pastor makes a good point, and then Jesus came and he rose from the third day, and then you go, mm-hmm, that's right. And then that's what they would say if they agreed with the preacher. Amen. That was like their way of saying amen. You ever been to church and they say that? Amen. Okay. That was what she would do. She'd go, mm-hmm, uh-huh. That's right, preacher. Keep talking. You'd hear her talk the whole like 2 hours, it seemed like. Okay. That's just how it was. So anyway, what am I talking about? Okay, the GCF is 6x. Then we had to divide each term by the GCF of 6x. And this is what I'm commending Chapel for doing. And I know Elena did it too, in her heart or on paper, hopefully, but at least in her heart. She divided both terms by that GCF of 6x. And I like how you wrote it, Chapel, as a fraction just in the problem. I think that's just an easy way for people to follow and for you to not get confused. I like it. 6x squared divided by 6x. Hey, 6 divided by 6, see ya. You got one thing at the top, you got the same thing at the bottom. They cancel each other out. Peace. But if you have 2 x's at the top, 1 x at the bottom, you divide that, that leaves you with 1x. That's where Chapel got the 1x. Mr. Morris, I'm confused. Okay, x squared, y'all, is the same thing as x times x. Y'all with me? It's the same thing. This is x squared. It's just the written out version. So if you got 1 at the top, you can cancel out 1 for 1, leaving you with 1x that you didn't cancel out. That's where my girl got x right there. Y'all with me? I like it. Okay? If you don't understand, come talk to me, but I like it. All right? All right. So right here, we got negative 24x divided by 6x. Hey, Chapel knew negative 24 divided by 6 is a negative 4. That's good. Plus you had an x divided by an x. The x goes bye-bye. The only thing left was negative 4. Couldn't have said it, showed it better myself. Okay? Very good. Nothing to critique. Very good, Chapel. Okay? Elena, do you have a question about anything I just explained right here? Because you're making some faces like you might. So just go ahead and get real with me.
For some reason, I could not remember anything we did in class, and my mom still hadn't sent me the video yet, so I literally only put down 6x of the answer. It's
Okay,
like
hold
that
on, hold on. Couple
all
of
the
things.
problems.
Elena, love you, girl. But a couple of things we got to talk about, okay, that I heard there that need to get said, okay? You said my mom didn't send me the video. I'm sorry. Are you blaming your mama for not watching the video? Okay, because I thought you were grown enough to watch your own video. See what okay? Listen, let's just get this out the way. I'm not being mad. I'm not being mean, but I'm telling you the truth, okay? I'm sending you guys the link to the class replay video in the same email with the homework. If you're able to physically open an email and look at said homework, there is also a link to the class replay video in the same email. I don't remember what you said, Chris. It's too hard. Click the link in the email and watch me say the same thing to you right then and there as much as you need to. Okay? Love you, girl, but no excuses. It's right there. I didn't have this ability when I was y'all's age. If the teacher said it and I didn't hear it, whoops. Here comes the test on Friday. Good luck, kid. Okay? You guys can watch the video and get a whole new experience and write it down and pause me and rewind me, and I don't even have to do anything. It's beautiful. Okay? Use it. But the link to the class replay video is in the email so that you can rewatch it when you inevitably forget. Because I know students and I know we forget after a while. Okay? But that's kind of how it is. So every single one of these, Chapel pretty much did what I was hoping that, she would do. If you look at each one of these, she said the GCF between 20, 15, 30 is 5. 5 times 4 is 20. 5 times 3 is 15. 5 times 6 is 30. Yay! And then Chapel kept it simple. She said, hey, all you really got to do is go with the variable that has the smallest exponent. That's also going to be your GCF. I said that on the video, but you have to watch the class replay video to probably hear me say it again. Okay? So I'm just saying. So 5y squared is the GCF. And then look what she did. Divided that thing. 20 divided by 5 is 4. Yes, ma'am. If you have 4 y's, you divide 2 y's, what do you got? Y squared. You got 2 y's left. 15 divided by 5 is 3. You got 3 y's, take away 2 y's, you got a y left. You with me? 3 take away 2 is 1. 1 y. If you go over here, hey, 30 divided by 5 is 6. If you have 2 y's and then you divide out 2 y's, you ain't got no y's left. Why? Okay, well, that's subtraction. Okay, I'm going to stop it right there because I've been going on for a long time, but I need to make sure I correct. If I don't correct it, then you guys are going to keep doing it the wrong way, and that's no good. Okay, Mr. Morris, what are we doing now? Let's talk. So one of the types of polynomials that you learned how to factor were when they're 2-term and 3-term, it's called factor by GCF. What we're going to talk about today, and I'll put it in the chat, in fact, I might write it on screen, is how do we factor quadratic trinomials. And this is something that you might want to write down because it's so searchable. Like you could put it in YouTube and find extra videos, Elena, if you forget what I said, or you can put it in Google and find some extra resources. Okay, I'm not picking on you too much, am I? Okay, so we're going to learn how do we factor quadratic trinomials. Okay, y'all got that real quick? Take a look at that real quick. How do we factor quadratic trinomials? Mr. Morris, that's a fancy word. I've never heard of such a thing. Yes, you have. We classified polynomials by degree and number of terms. So earlier, we learned if something has a degree of 2, it's called a quadratic. Right? I'm giving you an example, one right now. If something has 3 terms, that's where the prefix tri comes from. And so we call that a trinomial. That right there, if you want to give yourself an example, is a quadratic trinomial. And we're going to learn how to factor those types because it's a different process for quadratic trinomials than what you did for homework last week. Okay? Notice this example that I just put on screen does not have a GCF other than 1, right? And that doesn't help us. If you divide by 1, it still stays the same. So it's not really, I never conclude one with my GCF. There is no GCF, Chapel. There's no GCF, Marcelo. There's no GCF, Eliana. Look, x squared, 6x, 9. What do they got in common? Nothing. They don't got nothing in common. So how do you factor those types? We're going to talk about it right now. I'm going to give you one example, then we're going to do an exercise to help you get better at it, okay? It's kind of weird, but it's all about how it multiplies and adds. Mr. Morris, what are you talking about? Multiplies and adds? I know it's really weird, okay? But it's actually really easy once you get the hang of it. Chris, can you show me right now? Yes, Elena. You don't have to get excitable. You don't have to get too upset with me. I'm going to show you right now how to do it, okay? So take a look at this real quick. I'm going to put that same exact example. I just want to make the screen a little wider so y'all can see all the work and stuff. I want you to copy this down. Ask questions if you don't understand something. But we're going to use this really basic one that I just did. X squared plus 6x plus 9. This is a quadratic trinomial. There are 3 terms, 1, 2, 3. That's why they call it trinomial. But it's also a quadratic because the highest degree is 2. And remember earlier, quadratic means degree of 2 polynomial. Okay, so we call that a quadratic polynomial. The first thing I want you to do, Chapel, Elena, I want y'all to put two fairly wide parentheses right underneath that, because this is how this type is factored. It's broken apart into smaller polynomials that you could multiply and get what you had in the first place. Just like 9 factors to 3 times 3. Well, if you multiply 3 times 3, you get 9 again, right? So we're breaking this thing apart. Mr. Morris, how do you do it? The first thing I want you to do, sometimes Minnie Mouse just talks in the background with me. You'll get used to her. Go back to making bows or whatever you do. Okay, you put an X in each of the corners of the parentheses because X squared was the result of X times X, right? So if you're trying to break apart X squared, remember, it's really just X times X if you expand it. So we know we're going to go ahead and put X in both of those parts. Y'all with me? Now, this next part might be weird to some of y'all, but here we go. To do the next part, we got to know what numbers go here and what numbers go here. And to do that, it's actually quite simple. You have to think of two numbers that, if multiplied together, would equal the number on the outside. I'm going to put a little in there. It has to equal 9 in this case. So what two numbers can you think of if multiplied would equal 9? That's what you have to think about. But the thing is, Elena, those same exact numbers, if you were to add them instead, have to also, y'all with me? Have to also equal the middle number, which is 6. I'm going to put a little A over the 6. So you know that means adds to 6. And I'm putting an M next to the 9 because it has to multiply to the number on the right. It has to add to the number in the middle, but it has to multiply to the number on the right. I'll say it again. It has to add to the number in the middle, these numbers. But if you multiply these same numbers, it has to equal the number on the right. Chris, is that worth writing down? Yes. That's why I said it 2 or 3 times. It needs to add to the number in the middle. And those same numbers have to multiply to equal the number on the right. I'll put that in the chat because it's just so good. Okay? Find two numbers. I'll do it the other way. That multiply to the number on the right and add to the number in the middle. Okay? And for those of y'all, I spelled middle wrong, so you'll just have to forgive me. This is math class, not English, okay? Somehow it came out middle. All right, but I'm going to put it on screen so you guys who are watching the video can watch, can read it on screen. Okay, see how I spelled middle, y'all? It's like middle. It's like the middle, the middle ages or something. Okay, find two numbers that multiply to the number on the right, but they would add to the number in the middle. And so in this particular example, those numbers are 9 and 6. Hint, hint. Always start with what two numbers multiply in this process. Mr. Morris, why do I need to do that? Thank you, Minnie Mouse, for that question. Because there are only so many numbers that multiply to any amount. So you can narrow down your guessing and checking, and you can just add those factors and save some time. Always start with what multiplies. So let's go to Elena, because you're so much fun. Elena, give me the first two numbers that you can think of that would multiply and equal positive 9.
3,
Two numbers. Just 3? 3 times
3
4?
and 3.
Oh, 3 and 3. Okay, very good. Okay, 3 times 3 is what she thought of. Chapel, would you agree with that? Is 3 times 3 equal to a positive 9?
No, my mouth.
I know, it's funny. Okay, I'm sorry, my daughter's there. All right, she agrees. Now let's do the test, Elena. If I took those same numbers, 3 times 3, and I put them down here, and instead of multiplying them and I added them, is that also going to add and equal a positive 6, Elena? Okay, she says yes. Chapel, what say you? All right, they agree. If I can put a check mark to both situations, 3 times 3 is positive 9, but 3 plus 3 is 6, yay, then that's my winning combination. I'm going to put plus 3 inside the parenthesis, and I'm going to put another plus 3 for positive 3 inside the other parenthesis, and I'm done. This is how you factor a quadratic trinomial, excuse me. I don't know what a trinomial is. Okay, that's something else that you got to look up, but no, trinomial. Okay, now that doesn't seem too bad, but depending on the numbers, it can be kind of hairy. And by hairy, I mean, it could take a little more thought, but you can do it. You can do it. Y'all ready to see another example? Find two numbers that multiply to one number and add to the other. All right, we'll see if Chapel and Elena are really going to lead the way because here comes the next one. This time I'm going to change it to a different variable. Let's do it p. It doesn't matter. It doesn't have to be x all the time. We're going to do p, but this time I'm going to make the middle number a negative. We're going to do p squared minus 4p. Now let me think about this. Okay, yeah. And then I'm going to say minus... Ooh, this is tempting. I'm going to say minus 5. Okay? So this is a quadratic trinomial. It's quadratic again because the degree of the trinomial is 2. 2 means quadratic, but it has 1, 2, 3 terms to it. So that's where they get the trinomial part of the name, right? That's why we spent time classifying polynomials. Again, Elena, again, Chapel, again, Marcelo, Rachel. Start with 2 parentheses, and p squared really means p times p. You can just take that to the bank. Put the variables in each corner. But again, you're trying to find 2 numbers that if multiplied, now listen to this, multiply to a negative 5. And if added, listen to this, have to add to a negative 4. Chapel, you looked a little alarmed there. You okay? You gonna make it? Okay, you gave me quite a look right there in the camera. Okay, so it has to multiply. I'm gonna put it off to the side so you guys can see it. It has to multiply. When you see minus, think like negative, right? It has to multiply to a negative 5. But those same numbers, exact numbers, sign and everything, if you added those same numbers, they would add to a negative 4. There's only one combination that will work. And your job is to think that through. Again, to save yourself stress, Chapel, start with what multiplies. Okay? It narrows down your options and then you can check from there. But I want you to give me the numbers that you think it is in the chat, direct message to me if you can think of it. Don't send it to everybody because then you're giving away the answer and I want everybody to think. If you're watching the video, write it down on paper and let your mama look at it. Or email it to me. I don't care. I'll get to you as soon as I can. It has to multiply to negative 5, Elena. 2 numbers now. Start with that. Man, as soon as I put up those negative numbers, you guys, you just see the spirit suck out of the room. You're like, whoa. I mean, it looked like y'all saw a ghost. Don't be negative about negative numbers. They're real numbers, and we have to deal with them. Getting into high school level math, they're not going anywhere. We might as well get used to them. Those same numbers, if I added them, have to equal a negative 4. This is just so much fun, I can hardly stand it. Now, if you're getting depressed because of what I'm asking you to do, whether you're watching the video or live, it could be a sign. I'm not saying it is, but it could be a sign that you need to either practice and review your multiplication tables again, because you never quite learned them quite as well as you probably should have, maybe. That could be somebody. Or we need to have a discussion about how do we multiply negative numbers or add them, because that confuses you to no end. Or you're both. Now, I could probably help you the most with the negative stuff. The times tables I could help you, but it takes time, and you have to, there's really no way around it. Get on timestables.com, it's a free website, and just start learning them and drilling them. Okay, Elena looks like she is excited. She is successful. She has all the answers to provide for us, and she's just bursting with excitement and just anticipation to share her knowledge with the group. Is that how, did I read that right, Elena? I didn't, but heck. Okay, well, Chapel, maybe you know, a little more reserved. You make the faces, but I don't know. Maybe you're feeling that way. Maybe I picked up on the wrong student. Chapel, are you feeling like you want to give it a go? What are you thinking?
I have no idea what it is.
No idea? Not even one idea? Oh my goodness. I think we hit a brick wall, folks. We were rolling all day. Now we hit a brick wall. Okay. Again, let me just give you some gentle advice. Start with what multiplies. Start with what two numbers can you think of that multiply to -5. That's the only thing you need to really concern yourself with first. And surely y'all can give me a couple numbers that maybe multiply to -5 if you think about it. Elena, don't do that. Yes, you can. Yes, you can. What if I said, give me two numbers that multiply to +5? Would that be less scary? Elena, we're going to talk. Turn off the mute for a minute. Let's pretend for just a minute that that was not a -5. Let's pretend it was a +5. And I said, tell me two numbers that can multiply to equal 5. What would you say?
Only 1 and 5.
That's the only thing that equals 5, Elena. It's a prime number. Okay? Prime numbers can only be multiplied by 1 in themselves. So it's not really going to change just because I said -5. You know it's got to be 1 times 5 because 5 is a prime number. Now, the problem, Elena, that you're probably having is, I don't know, that doesn't equal -5, that equals positive. What is this negative business? Okay, can I tell you something real quick? Keep it real simple. As long as one of the numbers is negative, it makes it equal a -5 instead. Elena, did you hear me? That's better news than you're acting. As long as one of the numbers is negative, it's going to equal a negative version of that number. So I'm going to give you all some facts because apparently the whole group needs to hear this. If no one told you yet, I'm going to be the guy that tells you. This is true for multiplying or dividing negative numbers, okay? This is true for both. If the signs are the same, it's going to equal a positive number, okay? If the signs are opposite, like one's negative and one's positive, okay, it's going to equal a negative number. All right. So I'm going to put this in the on the screen so you guys can maybe jot that down because that's just gold. It's going to happen over and over and over. If you're going to be in Algebra 1 next year, whether you're doing curriculum on your own, going to a school, if you want to sign up for our year-long class, meets 2 days a week, love to have you. It's a good group. You're gonna encounter this like every week. Okay, so you got to just get used to it. If the signs are the same, let's say it was a -1 times a -5, they're both negative, it would still be a +5. But as long as one of the numbers is negative and one of the numbers is positive, if you're multiplying them, it will equal a negative product. It'll equal a negative answer. Are y'all with me? Now, the thing is, that's cool, Mr. Morris, but I don't have a clue if it adds to -4 or not. I mean, those same numbers have to also, if added, equal -4. That's the thing. I guess my question is, do they? If I went with that same combination, do they all? Okay, y'all like adding them. You just don't like multiplying them. Is that what it is? Because, yeah, that's what Elena said. Okay, the answer is yes. And there's a little rap I made for knowing how to add or subtract negative numbers. I don't know if I shared it with you guys yet or not. Y'all want to hear it? Okay. I found this. It's really a poem. That's it, a poem. But I'd rather rap it because I think it's easier to remember. When you're adding numbers that have negative, the rule goes like this. Let me make sure I say it right. Okay. Same sign, add and keep. Different sign, subtract. Keep the sign of the higher amount, then you'll be exact. A. Okay, that's my version of it. Same sign, add and keep. In other words, if they were both negative, you would just add the two numbers, 1 plus 5 is 6, and keep it negative. It would be -6 if they were both negative. If they're both positive, you add them up, keep them positive, right? Same sign, add and keep, right? But if they're different signs, you're actually subtracting the amounts. the number part gets smaller. So if one's positive, one's negative, you take 5 minus 1 is 4, right? But you keep the sign of the higher amount. 5 is bigger than 1. 5 was negative. That's why it equals a negative 4. It's a little rap. It helps a lot of kids. If you listen to me, it will help you too. Mr. Morris, that's so cool. Can you put that in the chat and put it on the screen? Yes, I can. Okay, you ready for this? This is my rap. It helps a lot of kids with negative stuff. This is when you're adding or subtracting, okay? Adding or subtracting negative numbers. I'm going to put it in the chat, then I'll put it on screen. Okay, you ready for this? It goes same sign, add and keep. Okay, that's the first line. Different signs, subtract the numbers. But then you got to keep the sign of the higher amount. Then you'll be exact. Okay, and you have to say it like that because it won't rhyme otherwise. Okay, same sign, add and keep. Different sign, subtract. Keep the sign of the higher amount, then you'll be exact. Hey, okay, you don't even act like that's not fire, Elena. That was fire. Okay, play it on your iPhone at night. Okay, and bump it in the car. Don't look at me like that. Okay, because it's going to help you calculating negative numbers. All right, put it on the screen, Chris. There's people watching the replay that need to see that. I got you. Okay? If you're struggling with negative numbers, like maybe a couple of my students today are, this could be a helpful little rhyme for you. If you're adding or subtracting negative numbers, you're going with my little rap. Elena thinks it's lame. I think it's pretty helpful. I think it's pretty awesome. I think it's better than anything on iTunes right now. Okay? But if you're multiplying or dividing numbers, it's just same signs are always positive, opposite signs are negative. Mr. Morris, is this really important? Yes, you're going to be really struggling this week if you don't learn these two facts, like massively. That's not nice. Still true. Okay, so once we figured out that 1 positive 1 times a negative 5 equals a negative 5, and positive 1 plus a negative 5 equals a negative 4, when I realize it satisfies both conditions, I put it in the parentheses like that. Plus 1 for positive 1, minus 5 for negative 5, and I'm done. I'm done. This is how you factor a trinomial, a quadratic trinomial. It's a very common type of polynomial that you'll see both with equations and when you're doing the factoring unit in Algebra 1. And so you need to get used to it. Okay, now be honest with me. Say it in the chat. Say, Mr. Morris, I need to work on my multiplication facts because I could be stronger. Or say, Mr. Morris, I just need to work on what do I do with negative numbers because I'm getting it's confusing. Your rap is amazing, but I just don't feel the confidence to rap it to myself. I don't know what you're thinking. But tell me what you're thinking. I got to get in tune with my students. What do y'all need? Okay, because I might have some supplemental videos that I could send you guys if you watch them, Elena, if you watch them. That could really help. All right. Chapel's good. I hope so. You're good? If you're not, that's okay. Just tell me. I'm just asking so I can help. You know, it's like going to the doctor. The doctor's like, how do you feel? You have a toe ache, but you don't tell them. Doesn't really help so much. Okay, practice multiplying with negatives. Okay, it's super simple, Elena. If it's multiplying that you struggle with, this is facts. It's a real simple thing to look at and make sure you don't get it twisted. If the signs are the same, negative times a negative, positive. Positive times a positive, positive. Same signs equals a positive. But the signs are opposite, it's going to be a negative answer. That's true for multiplying or dividing. Okay? All right, let's practice this little skill alone. Okay, so what you're going to do is you're going to factor quadratic trinomials for the week's homework, right? But before we do that, some of y'all, and by some of y'all, I mean all of us, okay, we're all in the same boat. We frankly need to practice just figuring out what numbers multiply and add to a given set. This will be good for you. So what I'm going to do is I'm going to show you on screen right now. It says find two numbers that multiply to a positive 6, but those same numbers add to a positive 5. Again, start with what multiplies. Pick two numbers and ask yourself, oh yeah, do those also add to positive 5? If they do, yay. If they don't, find two other numbers. Put it in the chat, girls. What multiplies to a positive 6 that also, if I added those exact same numbers, would equal a positive 5? Okay, I got one vote coming in. Let's see what we got. Thank you, Chapel. Very good. Ding, ding, ding. I give you credit. That is absolutely right. Elena, I'm sure she's sending it in right now. I'm waiting for you. Multiplies to positive 6, adds to positive 5. Ding, ding, ding. Way to go, ladies. It's 3 and 2, right? Isn't 3 times 2 6? But 3 plus 2 is 5. See, look, I got 3 fingers, and then I added 2 more fingers. Now I got 5 fingers. See, it's still true. So that's really what you're doing a lot of this week. It's just what multiplies and adds and training your brain to look for it. Now, here's where Elena looked like she wanted to shoot me in the head with lasers, but I know that she wouldn't do that in real life. But she looked that way, okay? That sounds bad. Can I say that? This is just a joke, guys, okay? But she just didn't look like she was as happy as she was a few moments earlier. There's a negative number, Elena. There's a negative number. It has to multiply to positive 6, but add to a negative 5. Again, start with what multiplies. I don't think they can recover after that comment. I just lost them. Oh, I'm sorry. Okay. Oh, rein it in, Chris. I'm sorry. Okay. But start with what multiplies. Chapel, Elena, I want y'all to think right now. What are 2 numbers that you can think of right now that multiply to 6? Get them in your head or write them on paper. Something times something I know equals 6. When you think of it, take those same numbers and add them and ask yourself, do they also equal negative 5? Oh, no, they don't, Chris. It equals positive 5 or it equals something else. Okay, good. Then throw that away and give me 2 different numbers that multiply to 6 and test those. Sometimes you got the right numbers, but you got to put the right sign on them. Because same sign, add and keep. Different signs subtract. Keep the sign of the higher amount, then you'll be exact. That song's fire, Elena. I don't care what you say. If anything, it's at least helpful. It has to multiply to positive 6, but those same numbers, if added, equal a negative 5. Can you think of it? Can you think of it? Elena multiplies. Oh, so close, Elena, but that multiplies to a negative 6, what you just sent me. Opposite signs equal negative numbers when multiplied. Okay, but that's a good effort. Was that Elena? Yeah, Elena. That multiplies to a negative 6. Chapel, you still thinking? Okay. Just so everyone can see, Chapel, I like her effort. I also like the fact she lets me play with her a little bit. I like to joke around if you haven't figured it out. But Elena tried one. She said, okay, well, what about negative 6 and 1, right? Well, while that does add to negative 5, yay! That'll multiply to positive 6. Opposite signs equal negative numbers. That's a positive 6, right? So, but that's what you need to do. Elena did good because she at least tried. She got some numbers, she looked at it. Now she's thinking, does it check both boxes, right? Let's see what else you guys are coming up with. Chapel's still thinking. I've lost Chapel in thought. She is gone somewhere deep. This is good. Okay, Elena's going again. Elena said, well, what if I did negative 1 times negative 6, Mr. Morris? That multiplies to a positive 6. Yeah, it does. Because remember, Elena, same signs equal positives if you multiply them. Elena, does negative 1 plus another negative 6 also equal negative 5, Elena? I'll do my rap again. I think you already hear it. Same sign, add and keep. So if they're the same sign, I just do 1 plus 6, which is 7, and keep it negative. Oh, that ain't negative 5. Nice try, though. What you're demonstrating, Elena, is exactly what y'all are doing this week. You have to put something out there, test it, trial and error. It's how you got to do it. Okay? So you're that much closer to getting the right one, Elena, because you know 2 of them that aren't it. I don't know what Chapel knows because she didn't send me anything yet, but I know she's about to. Okay. What do you guys got? It has to multiply to positive 6 and add the negative 5. Chapel, I love that effort. Chapel did -1. Can I say this? -1 and positive 6. Let's look at it and see if she's got it. She's looking hopeful. You guys look like contestants on American Idol. Like, did I make it? Did I get a contract? Okay. Hold on. Does that do it? Well, let's find out. If you have opposite signs, Elena, do opposite signs when multiplied, Elena, equal a positive or a negative? Elena.
Negative.
That equals a -6. Ugh. Also, that equals a positive 5 if you add them. Remember, same sign, add and keep. Different sign, subtract. Keep the sign of the higher amount. 6 is bigger than 1. Ugh. You guys are doing a great job. You're narrowing down the options. This is what it takes. Mr. Morris, I'm getting frustrated. That's okay. That's good for you. Give me something else. You've done a lot of different ones. Okay, I got another vote coming in. Thank you, Chapel. You said 3 times 2. Okay, 3 times 2. Does that equal a positive 6? Okay, we good then on that. Does 3 plus 2 also equal a -5? Does that equal -5? See, same sign, add and keep. They're both positive, so we keep it positive. That equals a positive 5. We need it to be a -5. But I would argue you're awfully close, people. This is the closest you have been. You've tried a bunch of options. You're just down to getting the signs right. I like 3 and 2. It multiplies to 6. 3 plus 2 does equal 5, right? I actually like those physical numbers. Y'all just have to think about what sign of these numbers do they have to be for them to be positive 6 and -5. You're so close. Don't give up now. Perseverance. Let's see. We got another vote coming in. Elena gave me a vote. Let's see what Elena's saying. Elena. All right, let's see. Elena says, well, what if, Mr. Morris, we made both of them negative, but kept them as 3 and 2? Well, let's talk about that. Let's think about that. Elena, is a positive, now think about multiplying rules, if the signs are the same, is that going to equal a positive or a negative? If the signs are both the same, they're both negative here, so they're the same.
Positive.
It's a positive. If you look at those notes I gave you earlier, when the signs are the same, when multiplying, they're still going to equal a positive. And -3 times -2 is a positive 6. Elena, I know you're starting to like my rap more and more. If I take a -3 plus another -2, does that give me a -5 as well? What do you think, Chapel? Does that equal a -5 as well? It equals a positive 6 when multiplied. What does my rap say? Same sign, add, and keep. They're both negative. 3 plus 2 is 5. So I keep it -5. Just like 3 plus 2 is positive 5, -3 plus -2 is -5. It's like saying, hey, Mom, can I borrow $3? I really want a taco. Mom, I need a piece of gum. I need to borrow $2 more. So I owe Mom $5 because I borrowed twice. And if I owe money, check with your bank, it's a negative amount in your bank account. Are y'all following me? This is this week's challenge, and everybody in here is smart enough to do it. You just have to get used to it. You just have to get used to it. Remember my rap. Same sign, add and keep, different sign, subtract. Keep this sign. That's for adding. But multiplying, what you also have to do, same signs are positive, opposite signs are negative. I got a video I put together a couple years ago. It's called Why So Negative? And it's going to help you not be negative about negative number calculation, Elena. That's what I need to give you, okay? Because that's the process we have to go through to factor trinomials, okay? So we got our work cut out for us today. You can do it. Try not to get a headache. Just drink some water. and pray to Jesus and get to it and try some trial and error. It has to do both, and that's what it is. Does that make sense, people? I mean, I know you got to practice it, but you understand what I'm asking you to do? That's what you'll be doing. Okay, guys, I'll leave it alone. We're already past time by about 10 minutes, so I better pause it right there. Watch the replay. Elena, guys, the replay is in the email with the homework assignment. So just click the replay if you need to watch it. You don't have to watch the whole thing. Just scrub it where you need to and rewatch if you need a refresher. I love you guys. Keep at it. Have a wonderful week. Say hey to everybody that I didn't get a chance to see live. I'll see y'all in the next one. Have a wonderful week.